All right, so we're looking at the rules for integration. Here are all the rules that we covered yesterday. And again, those are ones that really you do need to memorize. Are they in the formula booklet? Yes. Will you ever finish your exam if you are depending on your formula booklet that much? No. Okay? So, make sure you memorize them. And honestly, we're going to be doing so many of these that by the time if you do your homework, you'll have them memorized anyways. Okay, so, but if it takes you a little bit longer to memorize stuff, maybe take a little bit of time here, make yourself a couple flashcards or something, and really study these and make sure you know them. Okay. But let's look at an application, and I have a picture actually taken from Kognity that I think is really, really useful. Here they show the possibilities, okay? We've got this function in blue, all right here, this quadratic function in blue, and you guys know that if you take the integral of a quadratic, you're going to get a cubic, all right? You add 1 to the power, divide by the new power, so a quadratic becomes a cubic. So you have these red graphs that are all different possibilities for the antiderivative. Notice the capital F. You have a bunch of different possibilities. That's where the plus C, or that's what the plus C is doing, is it's stating, hey, we have all these possibilities, and more than just are drawn there, of course. But you'll notice here they identified one point, and they said we want the antiderivative that goes through the point -1, 2. Okay? Now the reason why that's significant is because that is going to tie us in to a unique answer. It's going to help us actually solve for what that value of C is, because we don't want just any of these. We want this specific solution. Okay? We want this specific solution, not any of the others. So we've got to find the correct value of C to do that. Okay, Ethan?
So, is the C a transformation or the number of antiderivatives?
No, C is a transformation. It's a vertical transformation. If C is one thing, it'll move it up to here. If C is a negative value, it moves it down here, or it might move it down here. Depending on what C is, determines where it's translated. Okay, but notice, with the reason why there are multiple answers is because if I had that translation, let's say I picked where x is, let's see, that looks like maybe 1, okay? All of these antiderivatives have the same slope at 1. You see that? They all have the same slope, so it doesn't matter, they would have the same derivative, okay? That's why we're able to translate it up and down and still get the same thing, okay? Now, look at a couple of examples of this. So we'll do one here. We're given the derivative function, and we're asked to find f of x, okay? Well, the integral of the derivative function will give us the original function f of x. All right, so we're going to take the integral of the derivative. So let's do that. The integral of 2 sine x minus, and I'm going to write that as x to the 1/2 dx. We know the rules for this. Okay, what's the integral of 2 sine of x? Yeah, -2 cosine x. Derivative of sine is negative cosine, and the constants along for the ride there. What is the derivative, not the derivative, the integral of x to the 1/2?
Isn't it 2x to the 3/2 over 3?
Perfect, yes. Okay, it's x to the 3/2. You have to divide by 3/2 so you can flip and multiply. So it's 2/3 times x to the 3/2. Okay, and then we have plus c. So here's what we want. We don't want just a family of possible f of x's with the plus c there. We want the specific one that will go through the point 0, 4. Okay? So, x equals 0 when f of x is 4. So we have 4 equals -2 times the cosine of 0 minus 2 times 0 to the 3/2 over 3 plus c. If you're given the y-intercept like we are here, don't just automatically assume that that's c. Sometimes it will be, sometimes it's not. Do the substitution and actually solve, okay? Because here, what is cosine of 0? Anywhere, what is cosine of 0?
1.
It's 1, so that's -2, that is 0, plus c. So c equals 6. And that gives us our final answer for what f of x is. F of x is -2 cosine x minus 2x to the 3/2 over 3 plus 6. That's the specific solution that will make it go through the point 0, 4. Okay?
So I have a question.
Yeah.
So you get the 2 sine x at the top, right? So you wouldn't do the thing where you put the 2 on the outside of the...
You can. You
Okay.
can. It's just a matter of if you need to do that, if that helps you at this point, yeah, go ahead and write that as 2 times the integral of sine of x,
Okay.
minus the integral of x to the 1/2.
Now, why don't you have to make it equal to 1? Why don't you have to put a 1/2 outside? I'm sorry, I'm just a little confused, I guess. Like for the 2. That was when you have to match it to
One of the properties that we looked at was if you're taking the integral of a constant times a function, that will equal the constant times the integral of the function.
Is
That's
that
what we're using here.
Is that on the... Okay, never mind.
That's another property of integrals,
Okay.
a different property of integrals. Alright, so that's one example. Look at another. What's a little different here? Yeah, we're given the second derivative. And we're asked to find the original function.
Oh, so do we have to take the integral of that and then the integral again?
Yes.
Nice.
Yes. Now, how you approach this one, we are going to take the integral of the second derivative, and that will give us the first derivative. So the integral of the second derivative will give us the first derivative, and then we'll take the integral of the first derivative to get the original function. Okay? How we go about handling the c's will depend on what we are given. Okay? Notice here we're given 1 point on the derivative and 1 point on the original function. It's important to note what points you're given, because since we're given 1 on the derivative and 1 on the original function, after we integrate here and we get f prime is equal to, what's the integral of 12x squared minus 4?
Same as...
Well, that's 3 over 3.
12x to the third over 3, so the 12 over 3 makes it a 4. So 4x cubed
minus 4x plus c.
minus 4x plus c. Okay? (12x cubed over 3 is 4x cubed minus
Oh, right.
4x
Okay.
plus the c. Now here's the thing. Sometimes you'll have ones where you are not told a point on the derivative. So you can't find this c yet.
We just do it again.
You would have to do it again and just treat it as a constant. Integral of a constant is the constant times x. But you'd be given 2 points on the original function. I'll show you one later on in the homework where that's going to happen. Alright? Here though, since we're given a point on the derivative, I can plug in 0 for x and negative 1 for f prime of x. So 4 times 0 cubed minus 4 times 0 plus c. c is negative 1, which means my first derivative is 4x cubed minus 4x minus 1. Okay?
So now we just take the integral of that.
Now we're going to take the integral of that. So let's do that. F of x is the integral of 4x cubed minus 4x minus 1 dx. And what is that?
X to the 4th.
X to the 4th.
2x squared.
Good. Minus a 2x squared.
Negative x.
Good. Minus x plus another c. Okay? Good. Good. Alright? So, now we've got to figure out what this c is. So we're going to use the point that they gave us on the original function. Okay? So we used the point on the derivative to figure out the c in the derivative. We're using the point here on the original function to help us find what c is there. So we have 4 equals 1 to the 4th minus 2 times 1 squared minus 1 plus c. Okay? 1 minus 2 minus 1 is negative 2. So negative 2 plus c is 4. Yeah, c equals 6. So now we know the function is f of x equals x to the 4th minus 2x squared minus x plus 6. And that right there is our final answer. Okay? Guys, this is how, when we knew the acceleration of gravity is negative 9.8, if we just know 2 locations, we can take the integral of acceleration of gravity, that'll give us our velocity, then we take the integral of that, and that'll give us our height. And if we know 2 different heights at different times, we can plug those in, use a system of equations, and figure out the height at time t formula. Okay? If we don't know the formula itself already. Alright? But here, sometimes you know what acceleration is, you don't know what your position is. Or you may be able to come up with a function for velocity, but you don't know a function for the position. Well, you can take the integral of the velocity to get your position. Okay? So you have, there's a lot of application here, and we'll do a lot of this application as we go through this unit. Okay? So, try one of these. This is just a one-stepper. I gave you the first derivative. Find f of x if f prime of x is x cubed minus 2x squared plus 3, and it goes through f of 0 equals 2. Okay, so what'd you guys do?
You
Find
take the
the-
integral.
You took the integral, alright, so what was the integral?
1/4 x to the fourth
1/4 x to the fourth.
minus 2/3 x to the third. Yeah.
Plus 3x plus c.
Plus 3x plus c, good,
Then you plug in 0.
And then-
I mean, you plug in 0 and make it equal to 2.
good. So 2 is
Equals to c.
0 minus
C.
0.
Yeah.
yeah.
And then you plug in 2 for c to rewrite it.
That's right. Okay, so f of x is 1/4 x to the fourth minus 2/3 x cubed plus 3x plus 2. Okay, here's a case where they gave you the y-intercept and that did happen to equal c. With polynomials, that will always work out that way. If they gave you f of 0, that's c. It doesn't work, as we saw with like the sine and that kind of thing, when you have other functions. But if you see a polynomial, then that'll save you a little work.
If you don't manage to get it down to the form that Murat had it at, it'll still work if you write it out as like x to the fourth over 3 minus 2x to the third over 3.
Yeah, yeah.
That'll still work, right?
Oh, yeah. Josh?
Oh, so my question was, I went down in the notes a little bit and I saw on the practice, it says answers in the back of the book leave out absolute value in ln of x, you shouldn't.
Correct. Yeah, as we look to practice here a little bit, if you look, remember these problems come from the Hayes and Harris textbook, all right? If you look on the Slater or actually in the PDF of that textbook at the solutions, the ones that have natural logs in them do not have the absolute value, okay? You should go ahead and include absolute value. What they're doing is they're just assuming, they're assuming that x is greater than 0 in all those cases, okay? I'd prefer that you be a little more exact than that, okay? Now, let me point out one other thing and then we'll be done here. Let's go down here. On number 3 here, A, B, and C are exactly like the example that we did, where you had to take the integral to find the derivative. The integral of the second derivative gave you the first derivative, and you could use this point to find what C is for the first derivative. Then you take the integral again to get the original function, and you use this point to find what C is. The last one here is a little different because notice they don't give you a point that's on the derivative. All they give you are 2 different points on the curve.
Oh,
What do you think?
tangent line or no? Just kidding.
System of equations.
No?
I'm just kidding.
What?
System of equations.
We're going to use a system of equations. So when you do the integral the first time, you could put C, but when you do the integral the second time, don't put C again because those aren't going to be the same values, okay? So you could put C1 and C2, or you could put C and D, or whatever, but here's the thing, they gave you 2 points, because you can plug in one point and get an equation with C and D, and then plug in the other point and get an equation with C and D, and you can solve the system that way, okay? And if you think about it, that's probably a little more realistic, because if this were an acceleration or something, it might be easier to find points on the actual like position than it would be to figure out how fast something is going at a specific time. Okay, so that's a little maybe a little more realistic there in that case. Okay?